So in part 2, we're going to start solving some polynomial inequalities. So our first example says we have the quantity x minus 3 times the quantity x plus 1 times the quantity x minus 5. And we want to be greater than or equal to 0. So notice two things. First of all, that it's already being compared to 0, so we don't need to worry about step 1. Also that it's already in factored form. So everything's been factored for us. And if not, we'll have to factor in the next one. Okay, what we need first are the boundary numbers. The boundary numbers are where the graph is going to touch, cross, interact with the x-axis, and that's going to interact with our y values in terms of being above and below. Those boundary numbers in the previous section, we called them zeros. We know what they are. So our boundary numbers for this particular graph are +3, a -1, and a +5. So coming from each of those factors. So I'm going to build a sign chart. And that's going to help me evaluate my function. So my sign charts, and again, there are a variety of ways to make these. This is just the way I learned to make them. So the first thing we're going to list is a test value. And then we're going to show some different rows. Each row is going to list one of the factors. So we have x minus 3. We have x plus 1. We have x minus 5. So each of my factors I list. Then I'm going to list the result. So this is what happens when we're all done, kind of thing. And then finally, I'm going to have a number line. And my number line is going to contain each of my numbers in numerical order, please. It is a number line. Put them in numerical order. Number one mistake I see. Then I'm going to have the lines. Okay. And that's my sign chart. So again, the test value, the number we're going to pick and test in each of our regions, each of our factors, and then the result of what happens when you plug the numbers into each of those. And then we'll finally pick up an answer. So what we need to do is pick a number that is less than -1 on the number line. So I'm going to use -2. You can use any number you want as long as it falls within this region of the number line. And then I'm going to take that test value and plug it in for the x in each of these factors. So -2 minus 3 is a -5. But actually, I don't really care about the size of the number. I just need to know that in this region, this factor is below the x-axis. So it's negative. So we're going to plug -2 plus 1. Well, -2 plus 1 is another negative. And -2 minus 5 is another negative. Now, what this is actually asking me is to multiply these factors together. So if I take this negative and multiply it by another negative and multiply it by a third negative, the end result is a negative number. So this tells me that the graph is actually below the axis. That's what it tells me. Now we're going to test something between -1 and 3. I always go for the easy one if I can. We're going to use 0. 0 minus 3 is negative. 0 plus 1 is positive. 0 minus 5 is negative. What happens if you take a negative times a positive times a negative? Well, we end up with a positive. So that tells me the graph is now come above and is doing this. What about between 3 and 5? Let's use 4. 4 minus 3 is positive. 4 plus 1 is positive. But 4 minus 5 is still negative. And if you multiply a positive times a negative, you get the negative. So the graph is back below. Trying something larger than 5, a 6. 6 minus 3 is positive. 6 plus 1 is positive. And 6 minus 5 is now positive. So the net result is positive. So we'll end up like that. Now we don't actually need the graph itself. I'm just trying to illustrate what it is doing. Okay, let's take a look at a couple of things before we go further into this. So -1, notice that that came from this factor, the x plus 1. And notice that on either side of it as a boundary number, the sign changed. And once it changed, it stayed that way. 3 comes from the top factor. Again, notice that once the sign went from negative to positive, it stayed positive, or it was negative to the left. And at 5, which is coming from the bottom factor, notice that it stayed negative until it hit that boundary number, and then it became positive. So some shortcuts you can take once you've done a lot of these. Okay, but we're not done yet because we haven't answered the question. So according to the inequality, we need the regions that are greater than or equal to 0. So we're going to pick greater than or equal to 0. Us the positive regions. That was not grammatically correct, but you understand. So the greater than or equal to 0 positive regions, that would be this region, and that would be this region. So we're going to pick those two as our answer. So our answer would go from -1 to 3. We're going to use brackets because the inequality has the equal to, it's inclusive, and then also from 5 to infinity. And there's our answer. So those are the regions where this graph falls below the x-axis. Okay, let's do a couple more polynomials. And each one's a little bit different. this is 2 part B. This time our polynomial was 2x to the third is less than a negative 8x squared. So it is not in the correct form we need. We're going to have to do a little bit of work first. So first we want to move everything to one side. Always go to the left side because it's easier to translate the above and below the x-axis. So that would give me 2x to the third plus 8x squared is now less than 0. But now we need to factor it in order to find our boundary number. So I'm going to plot an 2x squared. That's going to leave us with x plus 4. So our boundary numbers are a 0 that comes from that x squared. The 2 is meaningless. It's just doing some stretching. It doesn't impact where we're crossing the axis. And a negative 4. And now we can build our sign chart. So again, I'll have my test value. I'm going to start abbreviating that as TB for test value. My factors are the 2x squared. There's where I'll pull the 2 back into play. And the x plus 4. So then we have a line that's the result. Okay, and then we have just 2 numbers. Oops. That was not a lot of room to write stuff. So I'll move my number like that. This time the only numbers we have are the negative 4 and the 0. And now we're going to test in each of our regions and see what happens. So, to the left of negative 4, we're going to use negative 5. If I plug negative 5 into the x squared, you square it first. When I square that negative, it's going to become a positive. Times 2 is still positive. Negative 5 plus 4 is negative. And the net result when you multiply positive times a negative is a negative. Okay, let's test on the other side of negative 4. So between negative 4 and 0, we can use negative 1. Falls within that region. So negative 1 squared is a positive. Times 2 is still positive. Negative 1 plus 4 is a positive. The net result is a positive. What about on the other side of 0? So let's use, I don't know, 4, just to pick a number that's further out for no reason. 4 squared is positive. 4 plus 4 is positive. The net result is a positive. Wow. That's different from the first example. The first 2 ones, when we looked at them, they alternated signs down on the bottom, right? So you had a negative, positive, negative, positive. When we looked at the pictures of the graphs, they went from negative to positive to negative to positive. This one doesn't. Well, why not? Well, it's got to do with the multiplicity of that 0. We know that when we have a multiplicity that is even, the graph is bouncing and staying on the same side of the axis. So that 0 comes out of this 0 right here. And that's why the sign is not changing on either side of it. So I kind of expected something goofy or quirky to happen. So it doesn't impact what we're doing though. So what's our answer then? Okay, so this time, because the inequality is less than 0, and I need to pick it up from either of these 2 lines, not the original line, these 2 lines where we're comparing to 0. Less than 0 means we need to pick the negative regions. Our negative region, we only have one of them, is right here. So our answer is going to go from negative infinity to negative 4. This time we'll use a parenthesis because we're exclusive on our inequality. There's our answer. That was a little different with that. No sign change on either side of 0. For the most part, the factoring of these will be fairly straightforward. I wouldn't expect any really ugly factoring to happen because that's not what we're testing here. We're testing your ability to build those sign charts and pick the answers. Part C on this example shows us x to the third minus 2x squared minus 8x is greater than 0. So again, it's already compared to 0, but it's not factored. So we'll go factor it really quickly. Pull out an x. That's going to leave you with x squared minus 2x minus 8. And again, the reason you're factoring is so you can get to the boundary numbers. And the inside of that trinomial is going to factor into x minus 4 and x plus 2. Okay, let's come in and find our boundary numbers. So our boundary numbers are going to be a 0 from the x out in front, a positive 4 from the x minus 4, and a negative 2 from that x plus 2 is a factor. Then we'll build our sign chart. So our test value, x is a factor. We have x plus x minus 4 is a factor. It doesn't matter in what order you list them in x plus 2. So if you want to list them in a different order, please do. We have our result and our number line. This time our number line in numerical order has a negative 2, a 0, and a 4. Okay, let's plug plug something to the left of -2 in, like -3. Well, the first one's negative. -3 minus 4 is a negative. -3 plus 2 is a negative. When you multiply a negative by negative by negative, you get a negative. Between -2 and 0, we'll use -1. So the first one is still negative. -1 minus 4 is negative, but -1 plus 2 is now positive. So notice the sign change on either side of the -2. What's going on is a negative times a positive. That's a positive. Something between 0 and 4, we'll use a positive 1. So when we plug in 1, it's positive. Notice the sign change. 1 minus 4 is negative. 1 plus 2 is a positive. And positive times a negative times a positive. It's negative. Something larger than 4, 5 works. First one's positive. 5 minus 4 is positive, and 5 plus 2 is positive. The net result is a positive. So I again expect these signs to alternate because we don't have any multiplicities, impacting what's going on. Okay, according to the inequality, we need the regions that are positive, so we need to pick the positive regions. So for us, it's this region, this region. So then our answer is going to go from -2 to 0. We're exclusive again because the inequality does not have the equal to on it, and from 4 to infinity. And there's our third polynomial inequality. In the next segment, we'll talk about the rational inequality.